Well, hello there internet, have I got a smashing tutorial for you today. I will be teaching you how to install thin-plate spline motion models or TPSM. To you that means animating a static picture. I will let my friend Jeffrey here tell you a little more about it.
I'm gonna take some pictures. I'll pay you.
Whoa there, Jeff, why do you always have to be so weird? Never mind, I got this. Go back to doing whatever it is you do on your spare time, Mr. Delmer. We are basically taking a 2D photo along with a driving video underneath to move the 2D photo like a puppet. Here is some samples of what that looks like. You might have noticed the pictures with rapid movement didn't fare too well, but it is what it is. If you're using this as a smaller video inside a video, it works out pretty well. Check out Nerdy Rodent for examples of that. I will play with this to try and see if we can make it look better. You may have remembered in a previous video that we animated a person using Movio and it looked amazing, which was perfection, and this is the low budget free version. I still have more testing to do with this, and theoretically with training you can perfect the sample's movement and stop the background from moving. I also put a link in the description to upscale your video for free to improve the quality of the low quality video it renders. Just an FYI, training is when you take a bunch of samples of a picture and give it to AI overnight and say, hey, study those photos for a couple of hours and come back to me when you can produce better results. We will be using a pre-trained model, so we don't have to fool around with that.
Ain't nobody got time for that.
I got to be honest, I barely got the basic function to work, and it was not easy. Most of the tutorials for this, or directions, were all in Linux. I'm nerdy but not that level of nerdy. It took a while to get this to work in Windows 11, and I struggled for a couple of hours. This 10-minute install took me over 6 or more hours to figure out. The problem was due to Windows handling commands a little differently, and PyTorch not wanting to pull the correct version from the GitHub repository, as well as a dependency called Pillow not supporting the new version of PyTorch that I manually installed. It was riddled with problems. Fortunately for you, I was the guinea pig in this experiment, so you should have an easier time if you follow my tutorial. If you're running Linux or prefer, you can watch a YouTuber named Nerdy Rodent who has an excellent tutorial on this subject, and he does his entire videos using animated 2D faces, so you can see a lot of TPSM animated examples. If you're not subscribed to him, you should be, as he always comes out with the latest and the greatest. Links are in the description. So let's get started with a Windows install. It won't be easy, but it also won't take that long if you don't run into a million issues like I did. Hopefully I worked out all the kinks. Before we get started, I have two optional files for you to consider. The first one is the C++ runtime files that will prevent errors when you do the requirements update in an conda. This might already be in your computer. Then the second optional file is CUDA drivers, which are exclusive to NVIDIA. They are a whopping 4 GB.
That's a huge bit.
But it will optimize processing TPSM models and your stable diffusion renders. You may have to reinstall your stable diffusion if you install this after you installed stable diffusion. With that out of the way, first order of business is downloading the necessary files. Go to the GitHub repository link that I put in the video description and download the required files by clicking on the button that says code at the top right and selecting the drop down arrow to see the option to download the zip file. Awesome, you got the repository files. Pat yourself on the back. No, really, go do it now. Now unzip it to wherever your heart desires. May I suggest your desktop for now? Okay, scroll down a little bit on the GitHub link and find the pre-trained model files link. This is a Google Drive. Once you open it up, just download the pre-trained model called Vox and Ted.
Excellent!
and we will come back to them in a second. You will be grabbing this from a Google Drive. Now we need to install Anaconda. If you don't have it, this program is quite large.
Behemoth!
3 GB if I remembered correctly. While you are installing, you will need to ensure you choose the option to register Anaconda as the default Python. I left someone else's tutorial in my description. By the way, don't use normal Python, as Anaconda will simplify the process of creating a virtual environment with an earlier version of Python, and we won't have to switch versions all the time. Not to mention the commands we will be using will be completely different. We will also need Git. If you don't already have it, just type conda install Git when Anaconda is open to install Git, or download it from the Git website. Once Anaconda is up and running, we will need to create a virtual environment. Sounds complicated, right? That's where you're wrong. Just grab the code from the video description and follow along with the commands you see on screen. May I suggest putting all the commands I give you on a notepad for now? The first command will be conda create --name thin-plate-spline python equals 3.9. It is important that it says 3.9 at the end, because this is the version of Python TPSM is compatible with, and conda will create an environment appropriate for version 3.9. So don't get fancy and replace it with the newest version and get lost for hours. The next command is conda activate thin-plate-spline. Grab that from the description and paste it in command line by right-clicking anywhere in command prompt and then press enter. This will activate the virtual environment Anaconda created, which is mandatory to get this to work. And don't worry, the environment deactivates when you close command prompt sometimes, but pay close attention to the beginning of your command line now. It will have the name of the folder you activated in parenthesis. Make sure this is true before moving forward, or you might as well stare into space for an hour, which will be effectively what you're doing, wasting your time. Next is the command cd Thin-Plate-Spline-Motion-Model, which just brings you into the next folder directory in command prompt. You might think it has the same name as the folder we were in, but look again. You're wrong. And if you're right, you're still wrong, because you're heading towards disaster. That should be the name of your GitHub repository that you unzipped earlier, and not the same name as the conda environment you just activated. Also, there are other ways to skin this cat, but let's not get froggy. Now we will create a directory in here by typing mkdir checkpoints. You can also just right click in the root folder and create a folder named checkpoints, but you won't be as cool as me. Now let's drag the pre-trained models that we downloaded from earlier into the checkpoints folder we just created. These are the files we got from the Google Drive named Vox and TED.
Excellent!
As a side note, the Vox model is for shoulders on up or face animation, and the TED model is for TED Talk or half body models. I haven't tried the TED Talk one yet. Once that's in there, we are almost done. This is where things drove me nuts and left me confused for a couple of hours, and it won't be the last time. It screwed me.
Screwed me hard.
You will have to alter the requirements txt file, and this is not optional, which I thought Git would just fix this for me.
But it would be wrong.
So click on the requirements file and open with Notepad, then erase the lines for torch vision and torch, and you must set line for pillow to 9.2.0 because this is the version that works with the new PyTorch. If there is updates and you get an error with pillow, you will have to find the correct version that works with the version of PyTorch you install. I tried to correct this with pip.
Happy summer, gentlemen. Shut up, Pip. Righto.
And it threw me for another loop because it gave me the wrong versions. Once you make those edits to the requirements text file, just save and close it. Since we erased the lines for PyTorch, we will have to install this dependency on the front end, which means we're installing it right now.
Right now.
This is the part of the tutorial where it will really depend on your setup or the version at the time you watch this. Now, click on the PyTorch download link in the description. First you will see a PyTorch build, and normally you will be choosing stable and whatever version it says. And no, that doesn't stand for stable diffusion. Next, for OS it's pretty self-explanatory. I have Windows, so I'm choosing Windows. Now for package.
I've got a package.
He's got a package.
Choose conda. If you didn't listen to me and chose to stick with just Python, you will choose pip.
Righto.
Now for languages, Python. For compute platform you should choose the version of CUDA you are running, but I will have to explain this one as it is not a requirement. I will leave a link in the description if you want to download these files, but it's pretty big.
That's a huge bitch.
Basically these NVIDIA only drivers are for optimization of desktop applications and will speed up the performance of processes such as these ones. I haven't benchmarked it or anything, but so I've heard. In any case, I have CUDA drivers, so I choose CUDA 11.7. If you don't have them, or are running an AMD, choose CPU instead. You will see at the bottom that a code has been generated and run this command. Copy this code and right click in the command prompt to paste it in there, and press enter to run this code. It will now begin to install the latest version of PyTorch, or version you choose rather. If you're on Windows 11 do not skip this step, or skip editing the requirements document. Once PyTorch has finished installing we are almost done. Now for the moment of truth. It's time to install the dependencies by running the requirements document. Type pip install-r requirements.txt into Anaconda and press enter. This should take a minute or two. If you got some colorful text you will have to scroll back up and see where it all went wrong. Find out what was missing and try and satisfy that requirement. You can download missing things with the pip install command if the Git repository has it. Sometimes the name will slightly differ. For example YAML dependencies will be pip install pyyaml. You can Google the pip install command for it. For me, I ran into a lot of issues because I didn't have the Microsoft C++ runtime files installed, and pip won't install this for you. It took me a while to find that error. If you didn't hit any snags you're done. But wait, where is the UI? Well that's a funny thing you see. There isn't one. This will be run purely on Anaconda using the code in my description, which is also on the GitHub site near the bottom. I will have to explain this code though as it won't work by default. Just keep in mind, every time you run this, you will have to be in the activated TPSM virtual environment. Before we get started I want to mention that typing CLS and pressing enter will clear your screen if it's filled with clutter and you want a clean working space so you don't get confused by looking at previous errors, and holding Control then pressing C 2 times will stop a command that's stuck or taking too long. I did create a code that will work with the test pictures that are already in the repository under the assets folder, which is the video of Jackie Chan and the static image of President Trump. You can try the command that I labeled testing command if you just want to see if this works, but I'm going to break this down for you. Here is the code in an eggshell. You can get this code from the website, but wait, this command is for Linux, but we can use it with a slight variation. I had to find out the hard way though. That first part of the command that looks like a troll's comment in an online game, by that I mean the text in all caps, take that out, and you will paste that in separately. If you get the code to work all at once, well good for you man, but it doesn't seem to work in Windows 11, unless you separate it. Besides you will need to use the set function to start it off. So type set then CUDA visible devices equals 0. I didn't say underscore 3 times, but you should be copy and pasting this code from my video description anyways. This will select your GPU 0 to perform CUDA task, and no it doesn't mean you're disabling your GPU to use your CPU for this task, or setting any parameter to false. Boy is that confusing. This is one of the reasons I was stuck for hours, since I wasn't familiar with the set command in the Linux command was slightly different. If you don't have an NVIDIA graphics card, or choose to run this on CPU only, type --CPU at the end of the code. We won't touch that CUDA stuff again, unless we end the activated virtual environment session. Now we will focus on just the code after that part, which is what will drive our program. You can kind of tell what's going on here if you look at the code, so you can just copy and paste the test code in my link and be done with it. Just understand that -- equals a command and / is going from a folder to a subfolder. Also, the driving video and picture you choose will go in the assets folder as the resources to make your product. But let's break down each part. If you can tell what's happening here then go ahead and run the code, but for the rest of you, class is still in session. First of all we will be copy and pasting the part of the code that starts with python.demo onward. From now on, I'm replacing anything that says -- with the word command, and I won't be saying underscore while going over this code. So, command or dash dash config
But I thought you said...
You thought nothing.
is the first thing you see, followed by config/vox256.yaml, which is the library folder, followed by the file being accessed, which in this case is the vox256 YAML1. Next is the command checkpoint or dash dash checkpoint, followed by the folder checkpoint / the file being accessed, which is vox.pth.tar. This is the checkpoint for the face. If you are trying to do the half body and face, you will switch it to the TED1. For the next part of this code or command for source image, we can create custom folders to separate videos, images, and outputs like I did, but we will try the default paths first, and then I will go over customizing it. I left some code name, standard test assets, which will execute this code pulling all resources from the assets folder, which is the default folder. So the commands for source image, result video, and result video will all be pulled and saved in the assets folder. Any folder that isn't defined will choose from or spit out your output into the root folder. If you notice, the source image command is followed by assets/source.png. This is because the resource is in the assets folder and the resource or picture name is source.png, which is the Trump photo. The driving video command has a similar code after it, but we are using the driving.mp4 file of Jackie Chan. By the way, this source image and driving video are samples of what a perfect sample image and video look like for the Vox checkpoint, so strive to make your input images and videos like these samples. The last command is result video output. This was not part of the Linux code and I added this. If you don't add this, it will shoot your output into the root folder. If you can use your imagination, this command determines where your output video will go. So after the command we have output/test results1.mp4, which will be the name of the file. I must warn you that the new clip will overwrite your old clip unless you rename the new output to number 2 or 3 or so on. You should also stick to JPG, PNG, and MP4 video, but theoretically it should handle different formats.
Baby.
Now copy and paste your masterpiece into Anaconda by copying this text and right-clicking in Anaconda, and then press enter to run the command. You should see a progress bar in about 1 minute for this small task. If you have a 10-minute video, expect to wait 5 to 10 minutes to see a progress bar. If you suspect something is broken and need to stop the processing, hold Ctrl then press C twice. That's pretty much it. You can run the help command on this function to see all the commands for this program, but we went over the ones we need. There is no limit to the length of the animation you make. That I can notice is YouTubers like Nerdy Rodent animate an image the entire 15 to 30 minutes of the video. This program doesn't make very high renders. I will research ways to improve the quality, but for now, there is video upscalers, like Video 2x, but it's quite the hassle to come back in and try and improve the video quality. You can crop out the sides of the animation if the background starts to bleed and move with the head. Also, objects on the actor's head usually ruin the video as it tries to detect things attached to the model's head. Make sure your video doesn't make crazy movements, and keep in mind you haven't trained the image. That improves the result greatly. I will try and figure out how training works, but it's trial and error as this is made for Linux systems. I will see if DearGAN has better results, or if there is a more user-friendly option out there. Some last pointers, as you might run into some issues. Remember, if you get colorful text, it probably means there is an error and you will have to scroll up to see what the problem is. You can use pip install then the dependency name to normally install missing dependencies, but don't do that for Torch. Also, sometimes things won't install due to C++ runtime files not being present. CLS will clear your working space. Holding Ctrl and pressing C twice will stop a frozen runtime. Anything you have copied you can paste in Anaconda by copying this text and right-clicking in Anaconda. And last but not least, you will also have to be in the activated virtual environment each time you run this thing. Go to the beginning of my video to see how to do that. I will make another tutorial on how to get better quality video as well, where to get some driving videos and how to customize your folders. That's pretty much it. Sorry this video is a bit long, and I did a lot of complaining. I thought explaining what happened to me might help you avoid the same issues. If you made it this far then I absolutely love you, and please like and subscribe. With that said, take it away Monica.
Thank you for watching, and as always, sayonara, aloha, hafaday, adios, zaijian, alvida, annyeong, pa el lam, and please come again.